So for the next section that you're going to be reviewing for the AP test, it's the first part of derivatives. So that's knowing the definition of a derivative as the limit of the difference quotient. It's using derivatives to analyze properties of a function, knowing the connection between differentiability and continuity, calculating derivatives, higher order derivatives, and solving problems involving the slope of a tangent line. So the difference quotient is just the slope formula between 2 points on the curve. This first format of the difference quotient, you're going a tiny little distance away from your point, h in the x direction, which moves you f of x plus h to f of x plus h. So you can set up your slope formula. This is really, there's a missing x plus h, minus x here, which is why it becomes h in the denominator. And then the other way of thinking about slope is you have two different points, and this would be if you're on your x-coordinate, you have a point called x and a point called a, or maybe it's easier to think about it the other way, as a point called a and a point called x. And so the ordered pair here would be a comma f of a, and here would be x comma f of x. And you can set up a slope, a difference quotient between those 2 points, and then bring them closer together by bringing a towards x, so going this way. Anyway, you need to understand when you see that really that's the derivative. So sometimes on the College Board questions, they'll ask questions like the limit as h goes to 0 of sine of pi over 2 plus h minus 1 over h. And really what that's saying is, hey, my function is sine of x. I'm evaluating the derivative at pi over 2, so this would be cosine of pi over 2, because that's the derivative of sine, and that would be 0. So they're not really asking you to do the limit in that situation. They're asking you to recognize it as the difference quotient and realize that what you're going to do instead is the derivative. So one of the properties of being differentiable is, in order to be differentiable, your function has to be continuous. So if somebody tells you that you have a differentiable function, then you know that it's also continuous, and they don't have to tell you that as a separate thing. So this is a function, it's a piecewise function, and it's differentiable at x equals 2, so what do a and b have to be? So first of all, if it's differentiable, it has to be continuous. And to be continuous, that means that the limits as x approaches 2 in both directions have to match. So the limit as x approaches 2 from the positive direction would be 4a minus 2. And the limit as x approaches 2 from the negative direction would be 22 plus b. And we know that those two things have to be equal to each other. So 4a minus 2 has to equal 22 plus b because the function is continuous. So that's one piece of information that we get because of differentiability. The other piece of information is that if I make a slope function or a derivative, the derivatives also have to match. So the derivative would be 2ax minus 1 for x greater than 2, and it would be 11 for x less than 2. And these two things have to be equal to each other, so that as x approaches 2, so 2a times 2 minus 1 has to equal 11. So 4a has to equal 12, so a has to be 3. And then we can go back here and figure out what b is, because in order to be differentiable, it also has to be continuous. So we can use that to figure out, since a is 3, b would be 12 minus 2 equals 22 plus b. So 10 equals 22 plus b, so b would have to be negative 12. Just a reminder about differentiability. Derivatives don't exist at corners. When the two slopes from both directions exist, they are numbers, but they don't match. They don't exist at cusps when your tangent lines are approaching a slope of vertical, but in different directions, different kinds of verticals. So uphill vertical to the right and downhill vertical to the left. A vertical tangent means that you have a tangent line and it's a vertical tangent line. That means the derivative doesn't exist. Also, any type of discontinuity, jump discontinuity in this case, or even just a removable discontinuity, would not be differentiable. Your function has to be continuous in order to be differentiable. You should be comfortable in this unit with the product rule, which is just multiply both things together, but take the derivative of the first one, leave the second one alone, plus the first one left alone times the derivative of the second one. You should also know the quotient rule, and the poem that goes with it is helpful. And also the chain rule. The mathy notation for the chain rule is if you are taking the derivative of a composite function, then the derivative would be the derivative of the g, the parent function, with the function inside left alone, times the derivative of the baby. Okay. You should know notation for higher order derivatives. So the way Newton did it was with these tick marks, and the way Leibniz did it was with what look like exponents but aren't. That means the second derivative of y with respect to x both times. This would mean the third derivative of y with respect to x 3 times. And then Newton got tired of writing tick marks after 3 of them, so his now starts to look like an exponent but inside of parentheses, and that means the fourth derivative. And then there are some problem-solving types of problems involving the slope of a tangent line. So I have a function f of x equals natural log of x, shown in green, and it has a tangent line that passes through the origin. So we want to know the slope of this line. And so the big deal is realizing that the new calculus way of thinking about slope, so this has a point on it, right? The new calculus way of thinking about slope is going to say, well, the derivative of natural log would be 1 over x. Okay. At this point, which we don't know what it is, let's call it a, then the y-coordinate would be natural log of a, because this function in green is the natural log function. So at that a point, the slope is going to be the derivative, and that's going to be 1 over a. But you also studied algebra at one point, and so there's also an algebraic way of thinking about slope. And the algebraic way of thinking about slope is, well, if we pass through the origin, which is 0, 0, and we also pass through this point, we can do y2 minus y1 over x2 minus x1. So these two ways of thinking about slope are the same. They're both slopes, so they should be equal to each other. So 1 over a should equal natural log of a over a, which means that 1 should equal natural log of a, which means that e to the 1 should equal a, which means that a has to be e, which means the slope of the line would be 1 over e. This is one particular problem, but the idea is that you can think about slope both of those ways, that algebraic way and that calculus way, and you should be comfortable with switching back and forth between those ways of thinking about slope. That can give you a new problem-solving tool. Okay. Tonight's homework is the unit test for this unit on Khan Academy. Thank you so much.